Professor Livingstone is going to perform acts of kindness because he wants to pay it forward to his campus. And he decided that he's going to conduct an experiment where he performs an act of kindness for 2 students, and he wants to see how long it would take for the entire campus to receive an act of kindness. So what he does is he performs this act for 2 students, and then he tells these students, you have to perform this act of kindness, not that act of kindness, an act of kindness for 3 new students every single day. And so we're just going to assume, because sometimes in real life it doesn't quite work this way, so we have to make some assumptions. We're going to assume that everybody who receives an act of kindness goes ahead and follows through and continues doing 3 additional acts of kindness every day. And we're also going to assume that no one is repeated because, in real life, sometimes people end up just, stopping an experiment or so on and so forth. And so we have to assume these conditions so that we can look at it mathematically. So how long is it going to take for all 6,100 students to receive an act of kindness? Well, let's just think about this logically at first. So we have on day 1, 2 students have received an act of kindness. On day 2, each of those students gives an act of kindness to 3 students, so that would give us 6 acts of kindness. And on day 3, each of those 6 do 3, so that means 18. And so then it just keeps on going this way, and we're trying to figure out when we're going to get to 6,100. So let's go ahead and try to write an exponential function for this. We know a, which is our initial value, is 2, right? We started out with 2 students who are going to do these acts of kindness, and every day we're going to multiply the acts of kindness done by 3 because we're going to do 3 new students every day. So our exponential function is going to be y equals 2 times 3 to the x. Now you're going to be tempted to multiply that 2 and 3 together, and you're going to say, oh, that's 6 to the x. But remember, exponents are stronger than multiplication, so the exponent has to come first. So it's kind of like its own little thing. We can't just multiply the 2 and the 3 if we haven't already done the exponent. So we want to figure out, when is it going to be equal to 6,100? So that's going to be our final amount. When is our final amount going to be equal to 6,100? So that makes y equal to 6,100, and we are trying to find the x value. So let's go ahead and divide by 2 on both sides. We get 6,100 divided by 2 is 3,050, and that equals 3 to the x. Now, I don't know my 3's very well. I don't know this, so let's use a calculator and see, because I don't know that there's an exact number that could tell me 3 to the something equals 3050. So let's come to our calculators. We're going to go to the graphing menu so we can manipulate this function a little bit, and we're going to say y equals 3 to the x, and we're going to graph it. So this is our graph, and we're trying to figure out, when is y equal to 6,100? And we can't just look at the graph right now and see that, so let's use our table. So we're going to go to second and table, and we see up here that at time equals 0, we have 1. At time equals 1, we have 3. And so we keep looking, and at what point do we get to 3,050? Well, here at time equals 7, we have 2,187 people who have received an act of kindness, and then at time equals 8, we have 6,561. So in between 7 and 8, somewhere, it might be like 7.5 or something, we hit 3,050, right? Well, let's think about what this means in real life, though. Does that mean at time equals 7, did we have everybody receive an act of kindness? No, we didn't, because we didn't have that full number, right? But at time equals 8, we did actually. We surpassed the number that we needed. So on time equals 8 is when we're going to see the full campus has received an act of kindness. Now you might be wondering why I keep saying time equals 8 instead of day 8, because let's think about this. Day 1, what does time equal there? Do I put a 1 in this function right here? No, because on day 1, this is like nobody has received an act of kindness but the initial 2, right? So this would be y equals 2 times 3 to the 0. Right, so this is really time equals 0. This is our initial amount. Okay, so then this is time equals 1, and this time equals 2. So when time equals 8, what actual day are we talking about? Well, we're talking about day 9. So it seems that on day 9, all of the students on the campus would receive an act of kindness.